Alright guys, the topic for today is electricity and magnetism. And so last time we talked a little bit about magnetism with north and south poles. And we figured out that magnetism is created by moving charges. And this is through electric current or the atoms that make up that material. And so this becomes a very important topic for when we talk about electromagnets, which are magnets that are created by an electric current flowing in wires. And so this electric current is the movement of electrons that create a magnetic field. So for example, let's take some compasses, and of course those compasses are going to face north naturally, and then we have a wire in the middle with no current, no electricity going through. Well, the moment that we do introduce a current, as shown in the picture on the right, we notice that the compasses change direction. They're moving in the direction of the magnetic field. So, for example, let's say you had a compass near something that's producing current. This will affect the position of your compass and the way that it's showing direction. So a simple electromagnet is a coil of wire wrapped around an iron core. And so you could do this with an iron nail and just get some wire, coil it around. And then you can attach those two wires to a battery, and there you go, you have a magnet, an electromagnet. And so you'll always have a north and south pole because you're creating a magnet. Now we also have this thing called the right-hand rule, which shows you where the direction of the current is going. So for example, in this coil of wire, we can see the current is going to the right wherever the fingers are pointing. Wherever your thumb is pointing, that's where your north pole is. So north, it's on the top. So the creation of the magnet is through a current flowing through a wire, and a magnet moving through a coil of wire creates electric current. So when we say electromagnetic induction, this is when a magnet is moving through a coil of wire, which creates an electric current. So we see this electromagnetic induction in these pictures. So for example, I want to go through this one first. You see the lights are off because it's stationary, nothing's moving through the coil. So the current is 0. Now once we start putting the magnet into the coil, we see that the current changes. We have this negative value of current and the lights are on. Same thing goes if you're taking it out. It's still on and the current goes to the other direction. So how does a generator work? So a generator is a combination of mechanical and electrical systems, and it converts moving energy, which is kinetic energy, to electric energy. So for example, using a magnet to spin a rotor. Of course, we're going to know if you have two things that are the same, like south and south, they're going to repel. And so that's also creating a force, even if it's south and south or north and south, which is going to attract to each other. So first, the electromagnet, which is right here, repels magnet A and attracts magnet B. Okay, well that makes sense because we have south and south, which is going to repel, north and south, which is going to attract. And we see that the current is going a certain direction. Now, let's say the electromagnet switches. Now, we switch it. So north is here, so north and north is going to repel, and north and south is going to attract, and so the current changes here. So this is creating a movement. The switch from north to south is done by reversing the electric current in the electromagnet. So here's a picture of what you would see as a generator, and it converts mechanical energy, so this moving energy, to electrical energy. So this becomes very important, especially during storms when all your electricity in your house might be off. If you have a generator, this will create some electric energy for you to be able to still use your refrigerators, or if you have a house phone, you could use that, or TVs, radios. Motors convert electrical to mechanical energy, as we saw in the picture. Lastly, we have transformers, and this converts high voltage to low voltage. So you might have seen these on the road. These produce a high amount of voltage, and so what this happens is that not everything in your house or businesses can allow for that high voltage. We need to be able to convert some of that into energy that is useful, electricity that is useful. And so, for example, if you have a high power transformer, it can reduce the voltage, keeping the power constant. So we don't have a certain surge of high power and then low power. It maintains everything at safe levels.